This video shows an example of how to read a micrometer. In this case, a micrometer that is designed to measure things that are between 0 and 1 inches. The first thing to point out is that this is actually a two-dimensional drawing of a micrometer, but a micrometer is a three-dimensional object. So parts of this drawing don't look exactly as they would on the real object. The barrel and the thimble of the micrometer are curved surfaces, and as the surface curves away from you, it makes the lines and numbers on it look a little different than this. But I have been careful to make sure that the lines and numbers we're actually using for our reading this time, for this example, are arranged in a way that they would be in a real micrometer. There are three scales on the micrometer. The first one on the lower left is the main scale. This one is arranged so that you can see the 0, you can see the 5, and you can see these lines here that show where 1, 2, 3, and 4 would be. These are tenths of an inch. The last line that we can see as we read from left to right is the 5. There are more. There are lines for 6, 7, 8, and 9, but right now they are obscured behind the thimble. As you tighten the micrometer around the object you are measuring, the thimble moves, and it stops you from being able to see some of the lines. This is a good thing because it helps us to make our reading. The second scale we use is on the thimble, and it has these horizontal lines. We can see readings for 10, 15, 20, and 25, and there are other numbers that we can't see because they are around the curve on the other side of the micrometer. The final scale we use is the vernier scale. It is here on the top left. We see 2, 4, 6, 8, and 0. We use this part last. Let's start making our reading of this measurement. First thing we do is look at the main scale, and we, going from left to right, find the last line that we can see before the lines disappear underneath the thimble. And the last line we see is this one for the 5. That means the first number we need is 0.500. This means 5 tenths of an inch, or 500 thousandths of an inch. We write down 0.500. Now we look at the second scale that's on the thimble, and we're looking at the lines starting at the bottom. And we keep looking at lines until we find one that is below the main line here. The last line that we can see is the one for 12. And for this reason, we write down the number 0.012. Now we're using the vernier scale, the last of the three scales we need to use. We're looking for a line on the vernier scale that lines up perfectly with one of the horizontal lines on the thimble. The line that lines up perfectly is the one for 7, which lines up with the line for 20. We're not using the 20 for our reading though, it's the 7 that we want. Once we realize this is the line that lines up perfectly, we write 0.0007. as the last decimal we need for our reading. Notice how the line for 8 doesn't line up perfectly for the line for 21. It's a little bit above. And notice how the line for 6 also doesn't line up perfectly for the line for 19. It's a little bit below. We're looking for this pattern where the line that we use for our reading is neither above nor below, but it is surrounded by lines that are above and below. That's how we find the line we need. Now all we have to do is add the three decimals that we wrote down to get our final reading. 0.500 plus 0.012 plus 0.0007 gives us a reading of 0.5127. That is our measurement. It means that the piece we are measuring has 5,127 ten-thousandths of an inch as its size. Or more easily, we refer to it as 0.5127 inches. To summarize, we use three scales. We use the main scale to find the first number that we write down, in this case 0.500. We use the second scale with the horizontal lines on the thimble to find the next number we have to write down, which in this case is 0.012. And then finally we use the vernier scale to find the lines that match up to get us the last digit that we need, in this case 0.0007. We add these decimals together and we have our final reading.